Let's see the problem. We are given that x and y have joint density function little fxy equals 1 plus x times y over a, and that the absolute value of x and y is less than 1. The first function is find a so that the above defined is a valid joint density function. So we know if it's a valid joint density function, that the indefinite integral of little fxy equals 1, and it equals the definite integral from negative 1 to 1 uh, of indefinite definite integral from negative 1 to 1, that 1 plus xy over a dx dy, and it equals the definite integral from negative 1 to 1 that 2 over a dy, and it equals 4 over a, which equals 1, so a equals 4. The second problem is to find that x and y are uncorrelated or not, and prove it. So we first calculate the little fx. It equals the definite integral from negative 1 to 1, that 1 plus xy over 4 dy, and it equals 1 over 2. Similarly, little fy equals 1 over 2. So that's the expectation of x equals the definite integral from negative 1 to 1. That's 1 over 2 times x dx, and it's odd function, so it equals 0. Similarly, expectation of y equals 0. So now let's calculate the expectation of xy, and it equals definite integral from negative 1 to 1 of a definite integral from negative 1 to 1, that xy times 1 plus xy over a, and a equals 4, and dx dy, which equals 1 over 4 times definite integral of definite integral from negative 1 to 1 xy dx dy, and another one is x squared times y squared dx dy, and it equals 1 over 9. So we see that the covers of x and y equals 1 over 9, and it's not 0. So x and y are not uncorrelated. And the third problem is to judge if x, y are independent. So we have little fx and little fy. It's obvious that they are not independent. The next problem is to find the joint density function of x squared and y squared. We let z equals x squared and w equals y squared. So x equals positive and negative square roots of z, and y equals negative and positive square roots of w. So we can have the joint density function fzw, and it equals fxy. We use square root of z and the square root of w over the j. So we consider 4 cases, and it equals 1 over 4 times square root of zw, and the zw is greater than or equal to 0 and less than or equal to 1. The last problem is to prove or disprove that x squared and y squared are independent. So we first calculate the little fz, and it equals the definite integral from 0 to 1, that 1 over 4 times squared cw and dw, and equals 1 over 2 square root of z. Similarly, if w equals 1 over 2 times square root of w, and little f z times little f w equals little f z w. So they are independent.